Over the past few months, we've seen a lot of confusion in the mechanical, HVAC, and fire protection industries surrounding the EPA mandated shift to mildly flammable A2L refrigerants. Whether or not the construction industry is fully prepared, the transition is happening now, with significant impact already being felt in the multifamily residential sector and soon to be followed by commercial projects. The core issue is that many existing building designs don't account for this shift. These designs were drawn up using older refrigerants, most commonly R-410A, which is increasingly hard to source. Project teams are left scrambling, trying to figure out how to protect these new, mildly flammable refrigerants in their buildings in order to meet the latest code requirements. We at Conquest are getting inquiries from all corners: owners, developers, architects, engineers, general contractors, mechanical subcontractors, and authorities having jurisdiction, all looking for solutions. They want to know how flame bar A2L enclosure systems can address this critical need. My name is Luke Connery, partner, mechanical engineer, fire protection engineer, and leader of the commercial team here at Conquest. I want to walk you through some key challenges and solutions related to A2L refrigerants, which many in the HVAC industry are just now starting to hear more about. In this video, I'll cover three main points. One, the impact that A2L refrigerants are currently having on the construction industry. Two, the challenge that project teams face when it comes to protecting refrigerant piping as it runs through their buildings. And three, the solution. How can you solve this problem more cost effectively than you might expect, with minimal disruption to your project design and schedule? So let's begin with what A2L refrigerants are and why they matter. First off, A2L refrigerants like R-32 and R-454B are a class of mildly flammable refrigerants. They're being phased into use because of the AIM Act, which Congress passed back in 2020, which gave the EPA the authority to reduce the production and consumption of HFCs, also known as hydrofluorocarbons, by 85% over the next decade. HFCs, most commonly R-410A, are used in air conditioning and refrigeration systems, but they have a high global warming potential, or GWP. So why switch to A2L refrigerants? The answer lies in environmental regulations. The aim is to transition to next generation compounds with lower GWP, which contribute less to climate change. A2Ls fit this category, but the challenge is that they bring new design considerations and installation requirements. So let's break down the term A2L. The American Society of Heating, Refrigerating, and Air Conditioning Engineers, also known as ASHRAE, created a classification system to identify and categorize refrigerants based on toxicity and flammability. The A in A2L signifies lower toxicity, and the 2L means mildly flammable. These refrigerants aren't as flammable as others, but they can still propagate a flame under certain conditions, which is why they require special handling. Compared to prior generation refrigerants like R-410A, which falls under the A1 classification for non-flammable, A2Ls require special considerations during installation. Building and fire codes have been updated to address these issues. For example, ASHRAE 15, which is a key standard in this area, lays out specific requirements for A2L refrigerants to ensure safety. Here's where the challenge comes in. Many existing building designs were created with R-410A in mind. Now, as we shift to A2Ls, these designs may no longer meet code requirements, which could lead to significant modifications. According to the 2021 Mechanical Code, A2L refrigerant lines that penetrate 2 or more floor ceiling assemblies require at least 1 hour of fire resistance. If they penetrate 3 or more floor ceiling assemblies, they need 2 hours. This is a critical change that many project teams are grappling with as they update their plans. And then there's the ventilation aspect. A2L refrigerants require ventilation to prevent buildup of flammable gases in the case of a leak. This adds another layer of complexity, which we'll delve into shortly. So let's shift gears and talk more about how this all affects the construction industry, particularly here in North America. The first equipment impacted are going to be unitary split DX systems. These are direct expansion heating and cooling systems where part of the system is located outside, like on the roof or at ground level, and the other part is indoors. They're extremely popular because they're economical, energy efficient, and easy to install, especially in densely packed environments like low-rise, mid-rise, and high-rise multifamily construction. But here's the thing. HVAC manufacturers have already begun phasing down older refrigerants like R-410A. Some have moved quicker than others, and this has caused quite a bit of disruption. Project teams are scrambling to source this older equipment, but it's getting harder and harder to find. By 2025, just a couple of months away, only equipment manufactured before December 31st of this year can legally use R-410A in residential and light commercial projects. After that, A2L refrigerants will be the standard. So what does this mean for your project? Well, if you're relying on R-410A equipment, you might find yourself forced to redesign your system, and that can be costly. Worse yet, the conventional way of protecting mechanical, electrical, and plumbing systems in a building through shafts take up valuable space. These shafts are vertical compartments that run through multiple floors and are often lined with several layers of drywall to achieve the proper level of fire resistance. So here's the challenge. If your design requires dozens of these shafts, the space and cost can escalate quickly. And if that wasn't enough, you also have to factor in the possibility of a refrigerant leak. A2L refrigerants run through pressurized copper lines, typically between 200 and 400 psi. Even a small leak can rapidly release an entire system's worth of refrigerant into enclosed spaces. Since A2L refrigerants are heavier than air, they'll collect at the lowest point, creating a fire or even an explosion hazard. This is why ventilation is so important. The code mandates that shafts protecting A2L lines must be ventilated, either mechanically or naturally. Mechanical ventilation, with its detection systems, dampers, and fans, can be expensive, complex, and require extensive ongoing maintenance. Natural ventilation seems like a simpler solution, but it comes with its own set of challenges. For example, in humid environments and seasons of the year, natural ventilation can introduce moisture into conditioned spaces, leading to mold or mildew problems. This is something the project teams in regions with fluctuating humidity must consider. So now that we've outlined the challenges, let's talk about how flame bar A2L enclosure systems can provide a solution that addresses these problems more effectively and affordably than conventional methods. Flame bar technology uses an endothermic coating applied to the exterior of the galvanized steel. When exposed to high temperatures, this coating absorbs heat, allowing the enclosure to maintain its structural integrity for up to 2 hours at temperatures approaching 2000 degrees Fahrenheit. This is crucial when you're dealing with fire safety requirements. But here's where flame bar stands out. Because of its unique composition, it allows for the construction of fire-rated shafts using just one layer of drywall. That's a major advantage when compared to the multiple layers required by conventional drywall shafts. And because flame bar systems are compact, they can often be integrated into existing wall designs, reducing the need for additional space. For ventilation, flame bar A2L enclosure systems offer a range of options. You can choose between mechanical or natural ventilation, though most project teams prefer natural because of its simplicity. The gap between the flame bar enclosure and the surrounding drywall is usually sufficient to prevent condensation issues, but the flame bar product is available in both insulated and uninsulated versions, depending on the needs of your project. What about leaks? While any refrigerant leakage will naturally exhaust through 2-hour flame bar fire-rated duct at the bottom of the enclosure. And remember, the internal surface of every flame bar A2L enclosure is made of galvanized steel. So any incidental condensation will drain naturally the same way or harmlessly evaporate over time. This ensures that your building is protected from both fire hazards and environmental issues like mold and mildew. Flame bar A2L enclosure systems are also fully tested and listed for use with A2L refrigerants. This means you can be confident that your design meets code requirements and that you're providing the highest level of protection for your building occupants and assets. Flame bar fire-rated HVAC systems have a strong track record with more than 1,000 successful installations across the country and millions of square feet installed. If you're dealing with A2L refrigerant challenges, we'd love to help. Give us a call or visit our website. Details are provided at the end of this video and in the description below. We can assist with your specific project and offer educational resources for any interested project stakeholder. Thank you for watching, and we look forward to helping you navigate through this critical transition.